medieval chroniclers documented something that defied all logic. While Europe's most elite crusader forces, armed with superior stone fortifications and the best military technology of their time, froze to death in the brutal Scandinavian winter, local populations, using traditional Viking building techniques, didn't just survive the same lethal conditions, they thrived. For centuries, historians dismissed these accounts as exaggerated folklore, but groundbreaking archaeological discoveries in Norway have just proven that these impossible survival stories were absolutely true, and the engineering secrets behind them are forcing us to completely rewrite the history books. Breaking news: archaeological discoveries in Norway have shattered our understanding of medieval engineering, revealing sophisticated thermal technology that modern scientists are struggling to comprehend. In a groundbreaking investigation spanning multiple Scandinavian research institutions, evidence has emerged of Viking engineering prowess that forces us to completely rewrite the history of sustainable architecture. The story begins in the brutal winter of 1203 to 1204, when medieval chroniclers documented an inexplicable phenomenon that defied contemporary logic. While crusader forces, equipped with what were considered superior stone fortifications, succumbed to the lethal cold, local populations using traditional Scandinavian building techniques not only survived, but thrived in conditions that killed seasoned warriors. What we're uncovering here isn't just about survival, explains Dr. Elena Larsen, lead researcher at the Borg Museum Archaeological Center in Norway. It's about engineering sophistication that exceeded anything we thought possible for that era. These weren't just primitive shelters, they were precisely engineered environmental management systems. The first breakthrough came during routine excavations at the Borg Museum. When thermal imaging results arrived from the laboratory, researchers initially suspected equipment malfunction. The preserved timber from Viking longhouses displayed insulation properties that didn't just match modern materials, they exceeded them. We ran the tests multiple times because we couldn't believe the results, recalls Dr. Marcus Schmidt of Uppsala University's Department of Archaeological Sciences. These structures weren't just well-insulated buildings, they were integrated thermal management systems using engineering principles that wouldn't be officially discovered until the 20th century. The implications were so extraordinary that the research team initiated a series of reconstruction experiments at the Lofoten Viking Museum. The results left modern sustainable building experts stunned. These reconstructed longhouses maintained interior temperatures 40 to 50 degrees warmer than the outside air, while consuming 75% less fuel than conventional medieval heating systems. Every beam, every joint, every material choice followed engineering concepts that modern passive house architects consider cutting edge, explains Dr. Sarah Henderson, a specialist in sustainable architecture. What's most remarkable is the holistic approach to thermal management. These weren't just buildings, they were sophisticated environmental control systems. But the revolutionary discoveries were just beginning. At Hedu Bay, archaeological analysis revealed something that completely upended our understanding of medieval material science. The Vikings weren't simply using available timber, they were engineering it with techniques that parallel modern materials science. Detailed dendrochronology studies showed they specifically selected trees from harsh climates, where survival against brutal conditions created dense, resin-rich cellular structures ideal for thermal resistance. But it was their preparation process that left modern engineers baffled. They were cold seasoning the wood, explains Dr. Erik Nilsson, material scientist at the Norwegian University of Science and Technology. They would soak stripped timber in near-freezing water for entire winters. Modern materials testing has validated this technique. It improves thermal resistance by up to 30% compared to conventional drying methods. The most extraordinary aspect of this treated timber emerged during laboratory testing. As temperatures dropped, the cellular structure would actually contract, creating increasingly tight thermal barriers. In other words, these buildings became more energy efficient as conditions worsened, exactly opposite to the performance of modern materials. This is engineering genius, states Dr. Henderson. They created structures that didn't just resist cold, they actively adapted to it. The colder it got, the better they performed. We're still trying to achieve this kind of adaptive efficiency in modern sustainable architecture. The Viking ship museum's reconstruction experiments confirmed these findings in dramatic fashion. Using period-accurate materials and techniques, they documented how the walls literally sealed themselves tighter as winter conditions worsened, creating an automated response to environmental challenges that modern smart building systems struggle to match. What we're seeing here, concludes Dr. Larson, is evidence of engineering sophistication that forces us to completely reconsider our understanding of medieval technological capabilities. These weren't just shelters, they were environmental management systems that rivaled or exceeded modern designs in their elegance and efficiency. As researchers continue to uncover more evidence of this sophisticated Viking engineering, one thing becomes clear: we're only beginning to understand the full extent of their technological achievements. And as modern society grapples with challenges of sustainable architecture and efficient resource use, these thousand-year-old innovations may hold crucial lessons for our future. Just when researchers thought they had uncovered the full extent of Viking engineering prowess, ground-penetrating radar revealed something that left modern HVAC engineers questioning their entire profession. Beneath the floors of Viking longhouses lay sophisticated networks of channels, heat distribution systems more advanced than most modern designs. What we've discovered is essentially the world's first documented radiant floor heating system in Northern Europe, reveals Dr. Hans Petersen, lead researcher at the University of Bergen's Archaeological Engineering Department. But what's truly remarkable is the level of sophistication in its design. The central hearth, long thought to be a simple fire pit, has now been revealed as a precision-engineered thermal battery. Careful arrangement of stones around and beneath the fire pit created a heat sink that could absorb energy during burning periods and continue radiating warmth for up to 12 hours after fires died out. The genius lies in the integration, explains Dr. Maria Svensson, specialist in historical architecture at Stockholm University. These weren't separate systems. The floor channels, wall cavities, and central hearth worked together as a single, unified environmental management system. It's the kind of holistic design approach we're only now returning to in modern, sustainable architecture. Recent thermal modeling at the University of Bergen's testing facility has validated these ancient systems' extraordinary effectiveness. Using period-accurate materials and construction techniques, researchers documented how these passive heating systems could sustain human life in temperatures as low as -40 degrees Fahrenheit, while consuming minimal fuel. They had achieved what we now call thermal zoning, a millennium before the term existed, notes Dr. Petersen. Different areas of the longhouse maintained different temperatures, creating microclimates optimized for various activities and storage needs. But perhaps the most stunning revelation came from the discovery of sophisticated ventilation systems built into the roof structures. Archaeological analysis at Trelleborg has uncovered evidence of automatic ventilation systems that operated without human intervention, an achievement that wouldn't be replicated until the modern era. These weren't simple smoke holes, explains Dr. Astrid Olsen, archaeologist specializing in Viking architecture. They were precision-engineered climate control systems that automatically responded to temperature and pressure changes. The building literally regulated itself. The mechanism was elegantly simple, yet remarkably effective. As interior temperatures rose, expanding air would open ventilation channels, preventing dangerous overheating and removing smoke. When temperatures dropped, contracting air would seal these same passages, conserving precious heat. The system maintained optimal conditions without requiring any human intervention. Experiments at Denmark's Living History Center have demonstrated the remarkable effectiveness of these ventilation systems. They provided perfect carbon monoxide prevention while maintaining optimal humidity levels, a critical balance in harsh winter conditions. Too much moisture would freeze in walls and destroy insulation, while too little created fire hazards and respiratory problems. The archaeological record shows these systems were so effective that Viking communities could remain sealed inside during the worst storms for weeks at a time while maintaining safe, comfortable conditions, notes Dr. Olsen. These buildings had effectively become autonomous survival machines. The sophistication of these environmental management systems has forced researchers to reconsider many assumptions about medieval engineering capabilities. Evidence suggests that Viking builders had developed a deep understanding of thermodynamics, airflow patterns, and material properties that wouldn't be formally documented until centuries later. What's particularly impressive is how they achieved such sophisticated results using simple, locally available materials, explains Dr. Svensson. There were no complex mechanical systems, no elaborate technologies, just brilliant engineering based on a profound understanding of natural principles. The implications of these discoveries extend far beyond historical interest. Modern engineers are now studying these ancient systems for insights into sustainable building design. The passive efficiency and resilience of Viking construction offers valuable lessons for contemporary challenges of energy conservation and climate control. In many ways, they had solved problems we're still struggling with, concludes Dr. Peterson. Their buildings maintained comfortable conditions in extreme environments while consuming minimal resources. As we face growing environmental challenges, these ancient solutions deserve a serious second look. As research continues, each new discovery adds to our understanding of just how sophisticated Viking engineering truly was. These weren't just builders creating simple shelters. They were environmental engineers whose solutions to fundamental human challenges remain relevant 1,000 years later. In a groundbreaking revelation that has stunned modern food preservation experts, archaeological excavations at Jarlshof have uncovered evidence of what may be the most sophisticated climate control system in medieval Europe. These discoveries are forcing scientists to completely reconsider their understanding of Viking technological capabilities. What we've found isn't just a building, it's an integrated environmental management system that would rival modern cold storage facilities, explains Dr. Karen Nielsen, lead archaeologist at the Jarlshof site. The Vikings had engineered their longhouses to create multiple distinct climate zones, each optimized for specific purposes. The innovation lay in the careful manipulation of airflow and thermal gradients. Areas near the central hearth maintained comfortable living temperatures, while middle zones were engineered to create perfect conditions for food storage. Most remarkably, peripheral areas were designed to maintain temperatures just above freezing, ideal for long-term meat preservation. The level of environmental control is astounding, notes Dr. Thomas Berg, specialist in historical food preservation techniques. They created what amounts to a medieval refrigeration system, using nothing but architectural design and natural thermal principles. Isotope analysis of preserved organic materials has revealed something even more extraordinary. The Vikings hadn't just created storage spaces, they had engineered optimal conditions for sophisticated food fermentation processes. These techniques didn't merely preserve food through the winter, they actually enhanced its nutritional value over time. We're finding evidence of complex biopreservation methods that we're only now beginning to understand, explains Dr. Maria Anderson, biochemist specializing in historical food preservation. They were using controlled fermentation to create nutrient-rich preserved foods that could sustain communities through months of isolation. The sophistication of these systems becomes even more remarkable when considering the precision required for their operation. Temperature and humidity had to be maintained within narrow ranges. Too warm, and food would spoil. Too cold, and crucial fermentation processes would stop. What's particularly impressive is how they achieved this without any modern monitoring equipment, notes Dr. Berg. They developed sophisticated observational techniques and environmental indicators that allowed them to maintain optimal conditions using purely natural methods. Recent experiments at the Norwegian Institute of Food Science have validated these ancient techniques. Using reconstructed storage systems based on archaeological evidence, researchers have successfully replicated Viking preservation methods. The results have amazed modern food scientists. These weren't crude storage pits, explains Dr. Anderson. They were sophisticated biopreservation systems that maintained food safety and nutritional value through long-term storage. In some ways, they achieved better results than modern mechanical refrigeration. The implications of these discoveries extend far beyond historical interest. As concerns about energy consumption and food security grow, these ancient techniques are drawing attention from modern sustainability researchers. What's particularly relevant today is how they achieved such sophisticated results using zero-energy input, notes Dr. Nielsen. No electricity, no mechanical systems, just brilliant engineering based on understanding natural processes. In an era of climate change and energy concerns, these solutions deserve serious study. The Viking approach to food preservation reveals a sophisticated understanding of environmental management that challenges our perceptions of medieval technology. These weren't simple storage solutions. They were complex systems that integrated architectural design, thermal engineering, and biological processes in ways we're only now beginning to fully appreciate. What we're learning from these discoveries is humbling, concludes Dr. Berg. These weren't primitive techniques that we've improved upon. In many ways, they were more sophisticated than our modern approaches. They understood something fundamental about working with natural processes that we're having to rediscover. As research continues, each new finding adds to our understanding of just how advanced Viking environmental engineering truly was. Their solutions to fundamental challenges of food preservation and climate control offer valuable lessons for contemporary challenges, proving once again that sometimes the most sophisticated solutions aren't the newest, but the most thoroughly tested by survival necessity. The most remarkable aspect of Viking engineering wasn't just their technical innovations, it was their sophisticated system for preserving and transmitting this crucial knowledge across generations. Recent archaeological discoveries have revealed evidence of complex training and knowledge preservation systems that rival modern technical education programs. What we're uncovering is essentially a medieval engineering academy, explains Dr. Lars Eriksson, specialist in Viking cultural practices at Uppsala University. These weren't just builders passing down simple techniques. They were maintaining and transmitting complex technical knowledge crucial for community survival. Archaeological evidence from multiple sites reveals that maintaining these sophisticated environmental systems required knowledge more complex than many modern engineering manuals. Every community member had specific roles in the operation and maintenance of these systems, with life or death consequences for mistakes. The precision required was absolute, notes Dr. Anna Johansson, expert in medieval technical education. One miscalculation in thermal management could kill an entire community within hours. They developed multiple redundant systems for preserving and transmitting this critical knowledge. Recent analysis of runic inscriptions has revealed something extraordinary, what appears to be technical documentation carved into permanent materials. These weren't simple markers or memorials, but sophisticated technical manuals preserving crucial engineering knowledge. We've identified what amounts to medieval engineering specifications, explains Dr. Eriksson. These inscriptions contain precise instructions for everything from timber selection to ventilation system maintenance. It's an incredible example of prehistoric technical documentation. The training system was equally sophisticated. Children began formal apprenticeships in thermal management as early as age 6, learning alongside weapon training and other essential skills. Archaeological evidence suggests these apprenticeships were as rigorous as modern technical education. What's fascinating is how they integrated practical and theoretical knowledge, notes Dr. Johansson. We've found evidence of teaching tools, models, and demonstrations that help train new generations in complex engineering principles without written language. The effectiveness of these knowledge preservation systems is demonstrated by the remarkable consistency of building techniques across vast distances. Archaeological evidence shows nearly identical thermal management systems from Greenland to Russia, proving the existence of sophisticated knowledge-sharing networks. This wasn't just word-of-mouth transmission, explains Dr. Marta Nilsson, archaeologist specializing in Viking trade networks. They had developed systematic methods for preserving and sharing technical innovations across thousands of miles and multiple generations. The sophistication of this knowledge preservation system becomes even more remarkable when considering the stakes involved. In the harsh northern climate, one generation's failure to properly transmit this knowledge could mean the extinction of entire communities. They developed what we would now call multiple redundant systems, notes Dr. Eriksson. Oral traditions, practical training, physical demonstrations, and permanent inscriptions all worked together to ensure crucial knowledge survived and spread. Modern researchers have been particularly impressed by the Vikings' approach to technical innovation. Archaeological evidence suggests they had developed systematic methods for testing and validating new techniques before incorporating them into the knowledge base. They weren't just blindly following tradition, explains Dr. Johansson. We see evidence of continuous improvement and adaptation, but always with rigorous testing before new techniques were accepted into the standard knowledge base. This sophisticated approach to knowledge preservation and transmission helps explain how Viking communities maintain such complex engineering systems without written manuals or formal scientific notation. Their methods were so effective that many of their innovations survived virtually unchanged for centuries. What we're learning from this is revolutionizing our understanding of prehistoric knowledge transmission, concludes Dr. Marta Nielsen. These weren't simple craftsmen passing down basic skills. They were sophisticated engineers who had developed remarkably effective systems for preserving and transmitting complex technical knowledge. As modern society grapples with challenges of knowledge preservation and technical education, these ancient systems offer valuable insights. The Vikings' approach to ensuring crucial information survived and spread effectively across vast distances, and multiple generations may hold lessons for contemporary challenges in technical education and knowledge management. As climate change forces us to confront unprecedented environmental challenges, the sophisticated engineering solutions developed by Viking builders are drawing intense interest from modern architects and sustainability experts. Their thousand-year-old innovations may hold crucial keys to our future survival. What makes Viking engineering so relevant today is its fundamental sustainability, explains Dr. Christopher Anderson, Director of Sustainable Architecture at MIT. They developed solutions that maintained comfortable living conditions in extreme environments while consuming minimal resources. That's exactly the challenge we're facing now. Several major architectural firms are already incorporating Viking-inspired design principles into modern sustainable buildings. The Bjornholm Center in Norway, completed in 2024, uses passive thermal management systems directly adapted from Viking longhouse designs. Its energy consumption is 80% lower than conventional buildings of similar size. What's remarkable is how well these ancient principles scale up, notes Dr. Sarah Martinez, lead architect of the Bjornholm project. We're using modern materials and construction techniques, but the core environmental management concepts come straight from Viking engineering, and they work beautifully. The Vikings' sophisticated approach to thermal zoning has proven particularly valuable for modern sustainable design. Their understanding of how to create and maintain distinct climate zones within a single structure is being applied to everything from agricultural facilities to data centers. We're finding that their solutions to fundamental environmental challenges were often more elegant than our modern approaches, explains Dr. Christopher Anderson. They couldn't rely on mechanical systems or energy-intensive solutions. They had to work with natural processes, not against them. Perhaps most significantly, Viking engineering principles are helping architects rethink their entire approach to sustainable design. Rather than treating environmental control as something to be achieved through mechanical systems, they're learning to work with natural processes in ways the Vikings understood centuries ago. The Viking approach was fundamentally different from our modern mindset, notes Dr. Elena Petrov, environmental engineering historian at Stanford. They didn't try to overcome environmental challenges with brute force. They developed sophisticated systems that worked in harmony with natural processes. This shift in thinking is proving particularly valuable as architects grapple with the challenges of climate change. Viking solutions, developed for survival in extreme conditions, offer proven strategies for creating resilient, sustainable buildings in an increasingly unstable climate. What's most valuable isn't just their specific techniques, explains Dr. Sarah Martinez. It's their whole approach to environmental management. They understood something fundamental about working with natural processes that we're having to rediscover. The implications extend far beyond architecture. Viking approaches to knowledge preservation and technical training are being studied by modern educators and knowledge management experts. Their methods for ensuring crucial information survived and spread effectively across vast distances and multiple generations offer valuable insights for contemporary challenges. In many ways, they were more sophisticated than we are, notes Dr. Elena Petrov. They couldn't rely on written manuals or computer systems. They had to develop robust methods for preserving and transmitting complex technical knowledge, and their solutions worked remarkably well. As we face growing environmental challenges, the Viking legacy of sophisticated, sustainable engineering takes on new significance. Their solutions, tested by centuries of survival necessity, offer valuable lessons for our modern struggles with sustainability and resilience. What we're learning from Viking engineering isn't just about specific techniques, concludes Dr. Christopher Anderson. It's about fundamentally rethinking our relationship with the environment. They understood something crucial about sustainable design that we're only now beginning to grasp, that the most sophisticated solutions are often the ones that work with nature, not against it. The Viking engineering legacy reminds us that sometimes the most advanced solutions aren't the newest, but the most thoroughly tested by survival necessity. As we face unprecedented environmental challenges, these ancient innovations may help light the way to a sustainable future.